Hello. Welcome to today's lesson on understanding the origin of electrons in a circuit. We will be delving deeper into how current works and where the electrons in a circuit actually come from. Here's a roadmap of today's lesson. First, we'll examine the origin of electrons in a circuit. Then, we'll look at the battery's role in allowing current flow. So far, you have an overview of current, understanding it as the rate of flow of electrons. Today's lesson builds directly on that knowledge. Let's get started. Recapping what we have learnt in our last lesson, electric current is the rate of flow of electric charge through a conductor. But where do those electrons come from? A common misconception is that the battery in a circuit provides these electrons. In reality, the electrons that flow in a circuit originate from the material of the wire itself. Metals such as copper or aluminum contain lots of free electrons that are not bound to any specific atom and can move freely within the material. These are known as delocalized electrons. So, the electrons are already present in the wire, even before a battery is connected. The flow of charge that we measure as current is due to the movement of these delocalized electrons. If the electrons are already in the wire, what role does the battery play? The battery doesn't supply electrons. Instead, it provides the energy that pushes these electrons to move. When you connect a battery to a circuit, it creates a potential difference, or voltage. Voltage is essentially a force exerted on the delocalized electrons, causing them to drift in a specific direction. This directional movement of electrons constitutes the electric current. We will look at voltage in more detail in coming lessons. Imagine the electrons as tiny specks of dust scattered within the wire. In this analogy, the battery is like a wind breeze that pushes these dust particles, causing them to move consistently in one direction. It's important to understand that the electrons don't pile up at some location in the circuit or get consumed. They keep circulating within the closed loop of the circuit. When the battery pushes the electrons, they move from the negative terminal through the circuit and return to the positive terminal. This maintains a continuous flow as long as the circuit is complete and the battery remains active. In today's lesson, we delved further into the concept of current, particularly focusing on the origin of electrons in a circuit. We explored how the electrons that form the current within a circuit are already present in the wire, originating as free electrons from the metal atoms. Building on that, we clarified that the battery's role is not to create or supply these electrons, but to provide the energy needed to set them in motion, creating a flow of current.